Good morning, students. I know you guys are the ones who aren't able to make it to class. My name is Miss Hernandez. I just want to introduce myself real quick and how to navigate our Google Classroom. For now, I'm using fourth period as our as our demo class or whatever. And I know some of you might not be from fourth period, but I'm just going to use it so that I can show you what you need to do. So if you are going to be attending class, I want you to go to the classwork section and this daily routine. This daily routine that we have, fourth period virtual classroom, this is where you're going to be doing your check-in. Okay. If you couldn't make class, that's fine. It's fine. The only thing I'm going to ask you to do is I'm going to need you to do a daily attendance. So if you don't want to send me an email every day, go ahead and do this daily attendance. Click on it. You see how it turns into a hand? It'll click on it and it'll open up to Google Forms. And then I just need you to put your last name, your first name, your ID, today's date, and submit it. And this is what you're going to do every single day that you can't make it a class, and this will be your attendance, okay? That way it doesn't affect your truancy or it doesn't count against you. All right, here we have the school website, the high school website. If you need anything as far as Skyward, as far as counselor information, as far as reading Renaissance information, the library, everything is here. And if you click on it, it goes automatically. Okay, and then you click on whatever it is that you need. If you need the district website, that's this one over here. If you need the counselor's information, here's the counselor's information. If you need to talk to Miss Loya, her cell phone. If you need to talk to Miss Villarreal, her cell phone, her email. If you're a Gear Up student, down here, these two ladies are your people to go to, okay? They're really awesome if you need supplies and stuff like that. And then if you're thinking about taking college classes, Miss Gabby Valdez or Miss Lupita Villarreal are your people. Miss Valdez can help you with TSI. Miss Lupita can help you sign up for college courses in high school. All right. Now, if you're going to make it to class, you're going to click here and remember, classes from 11:20 to 12:10 if you're part of fourth period. If you're part of another class, well, just go to your virtual classroom and the Google Meet time will be there. You click on it here and it'll take you straight into our Google Meet. Okay. And we're only there from the time that it says. All right. If you go to the side, use the side arrow. This is where you're going to find what we did today. Okay. This will be changing on a daily basis. Okay. I don't know if maybe I can do a separate post, or maybe even I'll post a picture of this in Google Classroom every day. So that way you can have the journal and a picture of the CO and the LO to know what exactly you have to complete for the day. These journals are to be done on a daily basis. I need 4 sentences. If it's less than that, you're not going to get credit. But make sure you do those journals. Like this week, it's going to be called week 1. Make sure your name is on there. Make sure it's labeled week 1, and try and get all your journals on the same page. Okay, if you like to write a lot and it goes onto a second page, that's fine, but just save it as week 1, and then next week do a different document for week 2. If you go to the site again, and we also have our word wall for important vocabulary for this 3 weeks, or this period. In case you're in class and I ask you to get into groups, this will be the page that you go to and how to join your groups. You just click on the boxes and it'll take you to the group that you are in. Okay. I hope you don't have any questions on that. So that's our virtual classroom. All right. But today, after you do that, after you do your attendance, let's go back to the classwork. Right now, today, if you can, try and get this student parent information. This is basically what's happening here is this is where you're gonna put your parents' information, your student first name and last name, your mom's first and last name, and a cell phone, because sometimes the numbers that are on Skyward are really, really old. So try to get me some good information for that. Okay. Dad too. And who wants to be part of Remind? Remind is a messaging app that helps me send like a reminder to parents, like, hey, make sure that all journals are turned in Friday, and remind your student or whatever. If it's something serious, I'll call your mom. So I'm not going to use Remind to be like, hey, Miss Hernandez or Mr. Garza, your student is behaving badly. No, this is mostly just as reminders for assignments and stuff like that. Or maybe you forgot to do attendance, and you're marked absent. I'll use it for that. Okay. Okay. Now let's go and start. Okay, so that's the student parent. Once you're done with it, in order for it to go away on your tasks that need to get done, you're gonna go into it. You're gonna go into it. Sorry. You're gonna go to this page right here, and below it should say mark as done. Once you've done it, put it as mark as done, and it'll go away. Okay? It'll go away and you won't see that no more. All right, let's go Tuesday. This is kind of what we did yesterday. There's the syllabus. Read it. If you can, try and sign it. Okay. There is a way for you to sign it. It's called Kami. In order for you to download Kami, you're going to go to the Chrome store. I would just go to Google. Well, you would go to Google and then just go Chrome extensions. And then here you go to the web store. Okay. When you go to the web store, you're going to search for Kami. And the thing about Kami is that you can write on PDF documents. That's why I want you to use it. So here it'll say add to Chrome, and you just click add, and then you go in there, use your Google email to sign in, because the school has already paid for you to use it. But you need to be using your email from Google, from the district. Okay. And then after you do that, after you've downloaded Kami, hold on, give me a second. Let me switch you back. Okay, here. Once you're back, here, all you got to do is, you see how it says open with Kami? You're going to click on that blue box. It's going to take you to a different. It's basically going to take that PDF that we had and put it into Kami. Now, the question is, why, Miss? Why do I need it? Why do I need this Kami? Okay. So what Kami does is it allows you to text and write in PDF documents. Okay. So let's say your name is Hector Villarreal. Okay. And you type in your name, and then you just click here if you want to add another box. And if you want to erase something, you see that red X, click on it. Okay, save it. You see how it has the save or the download? I would download it to your computer or save it in your Google Drive. Either way, just save it or download it, and then you're going to just email it back to me. Okay, I mean, not email it, but post it in the assignment. Okay? And that's going to be Kami. Okay, and it's really, really helpful. Okay, sorry for just going back and forth, but all right. If I lost you somewhere, please let me know. Now, your behavior expectations, make sure that you follow these expectations. Read them carefully. The one that is big that I told everybody, don't take pictures or screenshots or record videos of Google Classroom. That is a big no-no, okay? Be on time and be respectful. Raise your hand. Don't make fun of people when you're on Google Meet, stuff like that. Let's see what else. Okay, now today's lesson, or Tuesday's lesson, we did cover CK12. CK12 is where our packets were created from. Okay, so CK12. Let me switch you into this tab so you can see it. CK12, this is our curriculum. This is your packet right here. Okay. It has basically reading, it has pictures, it has videos. I've already highlighted like the definitions and important information that you're going to need to copy into your notebook. You need a one subject spiral notebook. Unless you're one of those that takes up a lot of space, maybe get a 2 or 3 subject notebook. But the notes are in yellow, the ones that you need to copy for this section. Watch the video if you can. And this is your assignment, basically. If you answer these review questions and they're correct, you get 100 for the day. Okay, but if they're incorrect, obviously I'll send it back to you so you can do better. Or I'll just give you a grade if you don't submit it. If you don't resubmit it, okay? Now, remember, when you go to CK12, remember, the website is ck12.org. If you just Google CK12, it should do the same thing. It should find that CK12, go in, use your Google again to sign in because the school already paid for it, and you can go in and you can see it all nice and colorful like I do. Okay? Now, we went over the scope of chemistry. So how does soap relate? How does soap relate? How does soap relate to chemistry? Chemistry affects every area of our lives. Here's just one example of chemistry in action. The making of soaps was once made by boiling animal fat and ashes. Sorry. The product was hard on the skin and not very pleasant to use. Today, soap manufacturers involve complicated chemical processes to provide a wide variety of soaps in different skin types. Colors and odors can be custom made for that individual experience. Me, I'm very sensitive with my skin, so I can't use any soap. My soap that I use is Dove because it's a mild soap. It doesn't have a lot of chemicals and it feels good on my skin. Guys probably like to use those men's soap and not the ladies one because the men's soap, it's got a stronger odor, so when you guys start sweating and walking around, you don't, it controls that odor, that BO, that body odor that you guys might have. And I'm not saying that everybody smells bad. I'm just saying that that's just soap, okay? Or men's soap. What is chemistry? So chemistry, science is a general term used to describe the principled, rigorous study of the natural world. Many interconnected disciplines fall under this broader concept. For example, physics is the study of motion, biology is the study of living things, geology is the study of the earth and rocks and minerals of which it's comprised. Chemistry is the study of the composition of matter and the changes that matter undergoes. Matter is anything that takes up space and has mass. Okay, so this phone right here, it's matter, right? Anything that's in those pictures behind me, that mirror behind me, all of that is matter. Why? Because it takes up space and it has mass. Make sure you copy those definitions. Virtually everything around us is matter, including both living and non-living things. Chemistry affects nearly everything we see and every action we take. Chemistry explains why milk that is left in the refrigerator too long turns sour. Chemistry explains why certain pollutants called chlorofluorocarbons have done lasting damage to the ozone layer of our planet. Chemistry explains why okay, so let's stop there. So chemistry, if you think about it, we know that chemistry is happening to the milk, especially when it turns sour. How do we know it turns sour? It has a different smell when it's gone bad. It tastes different, and it even looks different. It looks clumpy, and it even has like a different color. Okay, so all of those are indications that a chemical change has occurred. Okay, that's why it's considered chemistry. Chlorofluorocarbons are released different ways. Sometimes it's by chemical plants, sometimes it's by cars, sometimes, it just depends. If you're burning stuff, you might be releasing chlorofluorocarbons because of what you're burning. If you're burning mesquite, I'm not really sure. I don't think so, but you never know. You might be releasing some of those CFCs. Chemistry explains why the leaves of deciduous trees turn from green in the summer to various shades of red, yellow, and yellow in the fall or autumn. So here you have a picture. You have different color of trees. You have some leaves that are green, some that are already like a red or orange or even yellow color. And look, that green is different than this green. Okay, this green is like super green, and this one's like yellow green. And then you have your orange and reds up here. Now, why is it considered chemistry? Because, like everything, it has run its course. Those leaves have lived, they were young, they were bright, and as they get older and start to die off, they change color. Okay, us as humans, we don't change colors, but we have different features that you can tell from an old person to a new person. I mean, or young person, not new. Chemistry touches every area of our lives: medicines we take, the food we eat, the clothes we wear, all the materials and more are in some way or another products of chemistry.
Does chemistry seem like the kind of thing that only old people in white coats can do? We're actually all chemists. Even our bodies are made of chemicals. When we eat, breathe, or just sit down, chemical reactions are taking place. All matter is made from some kind of chemicals, so chemistry is the study of everything. But how does chemistry occur in our everyday lives? The most obvious place is in the kitchen. When we cook something, a chemical reaction occurs. The raw meat turns into cooked meat so that our bodies can absorb the nutrients better. When we bake a cake, the ingredients cause a chemical reaction to create the batter. And then another chemical reaction happens when it goes into the oven. Even the way we store our food in the fridge and when things rot away are all chemical reactions. Another common aspect where chemistry occurs is through cleaning. Chemicals are created to target specific areas like dishes, laundry, and your body. Imagine using bleach to wash your...
So if you have bleach is like Clorox, okay? Now, Clorox is used in different ways around the house. Right now, this guy, he's using it to clean the floor. But can we only use bleach for the floor? No, we can use bleach in the restroom. We can use it in the kitchen on counters. We even use it in our washing machine when we're trying to make our colors look bright and white, okay? So chemistry is happening with bleach everywhere in our house.
your body. It would burn. But even children know not to use bleach to wash themselves, which means that the moment we start learning about what cleaning products to use, we are already junior chemists. Medicine is another important use of chemistry. The pills and medicine we use are all made from chemicals that are there to make our bodies stronger and to kill viruses and bacteria. Then things like fruits and supplements can be used to prevent illnesses, and these are also produced from chemical reactions. Basically, without medicine, which requires chemistry, we would get sick very often. And chemistry is used to research new medicines. Can you believe that about 100 years ago, people died from having a cold? It's because of discoveries in chemistry that we now have cheap medicines to get rid of the cold. Chemistry is also an important part of our environment. Fertilizers and compost for our gardens are created when chemical reactions take place. Think about how cow or horse dung is used to fertilize plants. People were doing it for centuries before scientists discovered how it actually works. But farmers started doing it after seeing how plants reacted to the dung. So even though they didn't study chemistry like you are, they were really good chemists. But there are more serious things to look at, like how some chemicals are nutritious to the environment and others cause pollution. Only through studying chemistry can we begin to discover ways to produce chemicals that are sustainable and not harmful to the natural world. In summary, we can see now that we're all chemists. From cooking food to cleaning ourselves, we make choices every day based on the way chemicals work. Chemistry is also important for the creation of medicines and environmental issues. By doing research in chemistry, we can find new cures for diseases as well as better chemicals to use in our natural environment. Chemistry can help change the world.
All right, so that's just a couple of ways how chemistry is all around us, whether it's fertilizer for using horse manure or cow manure. Chemistry can help us create good fertilizer from something that you don't think is great. And actually, it's really good because it's an organic fertilizer, meaning you're not putting any chemicals, bad chemicals into your grass. Which, of course, you got to remember if you use those chemical fertilizers, eventually, when you water it or when it rains, those chemicals are going to go into the groundwater and maybe come back and bite us in the butt. But who knows? Everything is different. Chemists look at the world in two ways, often simultaneously. The worlds of chemists are a macroscopic world and microscopic world. Macroscopic refers to substances and objects that can be seen, touched, and measured directly. Microscopic refers to the small particles that make up all matter. Chemists must observe matter and do experiments macroscopically and then make generalizations and propose explanations that are microscopic in nature. So, macroscopic, you got to think macro means big. So, that's things that you can see. For example, if you're using 100 milliliters of alcohol and 10 grams of potassium, that's microscopic substances because you can see them, you can touch them, you can measure them. But when it comes to microscopic, we mean micro, first off, is very, very small. Okay, so micro means like the small things that you can't see, the formation of gases, the electrons, the protons, the elements that make up that substance. Okay. Chemists must observe matter and do experiments macroscopically and then make generalizations and propose explanations that are microscopic in nature. For example, anyone can observe the physical change in appearance that occurs as an iron object, such as a tractor that is left out in the elements, gradually turns to rust. However, a chemist looks at the rusting tractor and thinks about what's going on with the individual atoms that make up the iron. So, macroscopic would be looking at the tractor and seeing the rust that's starting to happen. But in microscopic, a chemist is going to say, oh, well, this atom from the iron is reacting to the water and the air and the oxygen, and that's what's causing it to rust. Okay, so you know what I mean about macroscopic and micro? Throughout your study of chemistry, you will often switch back and forth between macroscopic and microscopic worlds. Okay, so here you have a macroscopic view of artillery shells. Artillery shells are those things that people in the military use to, throw these bombs or, make explosions that, will hurt other soldiers from the opposing, country or, militia or whatever it is. Now, if you look at this macroscopically, meaning from our picture right now that we're looking, we can see that are all the shells being rusted? No, only a couple. You can see this is rusted, this one's rusted, but if you look down here, this guy looks like he's brand new. This one too, brand new. But you look at this guy, he's rusted, that one's rusted. Okay? So that's the difference between macroscopic and microscopic. So here you have the summary. Make sure you read over the summary. Now, what's in yellow? That's your assignment for 1.1. If you answer those 3 questions, submit it. And you submit in full, complete sentences, and they're correct, you get 100. But if for some reason something's wrong, you didn't write complete sentences, I'll be taking off points, and I'll probably return it so that you can probably fix it and get your grade a little higher than it already is. Okay. That's 1.1. Now 1.12 is the scientific method. Okay, let me switch. Record this tab. Okay, so 1.12 is the scientific method. How can we use problem solving in our everyday routines? One day you wake up and you realize the clock radio did not turn on to get you out of bed. You're puzzled, so you decide to find out what happened. You figure that there's 3 possible explanations. Number 1, there was a power failure and your radio cannot turn on. Number 2, your little sister turned it off as a joke. Number 3, you did not set the alarm last night. Okay, so those are your hypotheses. There's 3 possible reasons why your alarm didn't go off in the morning. So let's continue our investigation. Upon investigation, you find that the clock is on, so there was no power failure. Your little sister was spending the night with a friend, and she could not have turned off the alarm. You also notice that the alarm is not set. Your forgetfulness made you late. You use the scientific method to find an answer to your question. Okay, you have used the scientific method to find the answer to your question. So there was 3 possible reasons. It wasn't the first one because the radio was still on. It wasn't the second one because little sister was out at a friend's house. And number 3, it is the reason you just forgot. Maybe you were in a hurry, maybe you were tired, whatever it was. Okay, but that you just did the scientific method right there. So scientific problem solving. Humans have always wondered about the world around them. One of the questions of interest was and still is, what is this world made of? Chemistry has been defined in various ways as a study of matter. What matter consists of has been a source of debate over the centuries. One of the key arenas for this debate in the Western world was Greek philosophy. The basic approach of these philosophers to question about the world was discussion and debate. There was no gathering of information to speak of, just talking. As a result, several ideas about matter were put forth, but never resolved. The first philosopher to carry out the gathering of data was Aristotle, and he was around in 304 to 333 BC. That was a long time ago. He recorded many observations on the weather, on plant and animal life and behavior, on physical motion, and a number of other topics. Aristotle could probably be considered the first real scientist since he made scientific observations of nature and tried to understand what he was seeing. So this is a picture of Aristotle. Look at that wise old man. He was our first scientist. Okay. Inductive and deductive reasoning. So more than likely, these guys are going to be definitions that you need. But let's read first, and then I'll decide what you need to write down in your notebook. 2 approaches to logical thinking developed over the centuries. These 2 methods are inductive reasoning and deductive reasoning. Inductive reasoning involves getting a collection of specific examples and drawing a general conclusion from them. Okay? Deductive reasoning takes general principle and draws specific conclusion from the general concept. Okay? Both are used in the development of scientific ideas. Okay, so let's go into more detail about what that means. Inductive reasoning first involves the collection of data. Okay, so first you need to find collect everything, all the information possible. If I add sodium metal to water, I will observe a very violent reaction. Every time I repeat the process, I see the same thing happening. I draw a general conclusion from these observations. The addition of sodium to water results in a violent reaction. Okay, so you collected your data. What did you do? Well, you mix sodium metal in water, and what's happening? Well, a reaction is happening. You don't know we don't know exactly what it is, but if there was light, you record that there was light. If there was gas being released like bubbles, you record. If there was a color change, all of that is inductive reasoning. Okay. In deductive reasoning, I make a specific prediction based on general principle. One general principle is that acid turns blue, litmus paper red. If I have a bottle of liquid labeled acid, I expect the litmus paper to turn red when I immerse it in the liquid. So you know some information, and so you know that acids will turn red to litmus paper. Okay. Now, if you want to check if a substance in a container is an acid, well, you dip that paper in there, you dip it in there, and when you take it out, if that little litmus paper turns red, okay, this is an acid. But what if it doesn't turn red? Well, then you can say it's not an acid. That is deductive reasoning. Okay, there's a video. I wonder how long it is because I don't have much time.
In this video, I will briefly describe the difference between deductive and inductive logic. I will also explain the connections between the two and show how both kinds of logic are important for knowledge production. In fact, they can be envisioned as integral parts of an overall cycle of research, as both connect theory with empirical observations. Deductive logic is sometimes referred to as a top-down approach because it starts with abstract theory, which we often envision as higher, and then moves to specific empirical observations. When researchers use deductive logic, they first start with a broad theory. They then articulate specific hypotheses to test that theory, and then systematically collect data by which they can test their hypotheses. If the data support the hypotheses, then the theory is also supported, but it's not proved either. If the data do not support the hypotheses or hypothesis, then the theory is not supported, but it's also not disproved. So, for example, let's say that I have a theory that women are smarter than men. I would then need to generate some hypotheses or predictions to test that theory. Hypotheses are always stated as if-then statements. So I might say, if women are smarter than men, then they should have higher GPAs. I would then look at the GPAs at both women and men within a particular setting and see if there's a difference. This is my empirical observation. If women's GPAs were on average higher than men's, then my hypotheses or prediction would be supported, and that could then potentially also support my theory. Note that the data would not and cannot prove or disprove my theory. Instead, it can only support or not support my theory. So the goal here is to test theory. And to do this best, this usually involves statistical analysis in large numbers of cases. In contrast, inductive logic is sometimes referred to as bottom-up logic. Here, researchers start with making broad empirical observations. The goal here is to build theory, not to test it. Often, not always, inductive research involves qualitative data. So looking at a few cases with the eye towards deep, nuanced, and a meaningful understanding of those cases. So for example, a researcher who is interested in student learning may observe students in classrooms and also talk with them after class about their experiences. The researcher may then begin to find patterns in terms of some students being more likely to participate in some classes than others. After collecting sufficient amount of empirical data, the researcher may then be able to start making some tentative hypotheses to explain these patterns. And from there, a theory of classroom engagement and success may begin to be built. In sum, when researchers use deductive logic, they first start with a broad theory and then articulate specific hypotheses to test that theory, and then systematically collect data by which they can test their hypotheses. When researchers use inductive logic, they start with observations and from there start to see patterns and from there start to develop theory. In truth, people are often using both kinds of logic simultaneously. We both come into situations with existing ideas about the world, and we also hopefully are open to collecting new information to then revise our existing ideas about the world. But it is important from a researcher perspective to be able to differentiate between the two in order to systematically evaluate the process by which we are making our conclusions.
Okay, so that was maybe some extra information on inductive and deductive research, okay? And if you need to see it again, you can go ahead and see it on CK12. The idea of the experiment, inductive reasoning is the heart of what we call the scientific method. In European culture, this approach was developed mainly by Francis Bacon, and he was in 1561 to 1626, a British scholar. He advocated the use of inductive reasoning in every area of life, not just the science. The scientific method was, as developed by Bacon and others, involved several steps. First, you have to ask a question. Identify the problem that's going to be considered. Number 2, make observations. Gather data that pertains to the question. Number 3, propose an explanation, a hypothesis for this observation, for the observations. And number 4, make new observations to test the hypothesis further. And there you have a picture of Mr. Bacon. Okay, we're almost done because I'm running out of time. Note that this should not be considered a cookbook for scientific research. Scientists do not sit down with their daily to-do list and write down these steps. The steps may not necessarily be followed in order, but this does provide a general idea of how scientific research is usually done. When a hypothesis is confirmed repeatedly, it eventually becomes a theory, a general principle that is offered to explain natural phenomena. A noted keyword explanation. The theory offers a description of why something happens. A law, on the other hand, is a statement that is always true but does not explain why. The law of gravity says a rock will fall when dropped but does not explain why. Gravitational theory is a very complex and incomplete at present. The kinetic molecular theory of gases, on the other hand, tells what happens when a gas is heated in a closed container. The pressure will increase, but also explains why the motions of the gas molecules are increased due to the change in temperature. Theories do not get promoted to laws because laws do not answer the why question. Let's see how long this one is. Okay. I don't have time because I have to go to my next class. So make sure you read over the summary, answer the questions at the end. If you have any questions, reach out to me. Okay. I know you guys are going to be working on your own, but there's no reason why you can't send me an email and me try and help you when I can. All right. So have a great day. And remember, this is due as soon as you can turn it in. I know there's a due date, but don't worry about the due date. I'm going to be flexible this week. Okay. Next week, maybe we'll be a little bit more rigid, but for now, just turn this in as soon as you can.